Tell me when you will be mine. I'm teasing. Relax. Okay, Alan, what are we solving today?
Good day, everyone. Welcome to another solution walkthrough on Leetcode Simplified. I'm Alan, and today we're going to explore two different ways to solve Leetcode 257 binary tree path. Given the root of a binary tree, return all root to leaf paths in any order. For example, this tree has two leaves, so naturally we get two paths. The first path goes from root 1 down to leaf 5, and the second path goes from root 1 down to leaf 3. Therefore, the resulting paths are. When dealing with the tree problems, recursion often feels like the most natural fit. So let's jump right in with the most common and cleanest approach, depth first search using recursion, where we build the path string as we traverse down the tree. We'll start by creating an empty array to store all our root to leaf paths. Next, create our helper function to handle both the recursive traversal and the path building logic. We will call it with the root and an empty initial path. Now let's walk through what our helper function does exactly. If node is none, that means we hit an empty pointer. Simply exit. If no left child and no right child, meaning it's a leaf, we finalize the path by appending to the paths array the current path string concatenated with current node value, and then exit. Otherwise, this node is not a leaf, so we continue building the path string by adding the current node value, followed by an arrow. Then we explore left subtree and right subtree. After all the recursive calls finish, return the list containing every root to leaf path strings. Okay, let's give it a try. Hit submit, and boom, accepted. This recursive depth first search approach is one of the cleanest patterns you see for top-down tree problems. Time complexity is big O of n because we visit each node once. Space complexity is big O of h, where h is the height of the tree due to recursion stack.
That's great, Alan. But can you do it without recursion?
Absolutely, Lucy. Let me demonstrate a breadth first search perspective, an interactive method that avoids recursion entirely. We leverage the deck module from Python collections packet to store tuples of nodes and the path string leading to them. Let's begin. If root is none, that means there's no tree and no paths. Simply return empty array. Initialize an empty array to store our path strings. Initialize a queue using a tuple containing the root and its values at the starting path. As long as the queue isn't empty, pop from the left and unpack the tuple into two variables, node and path. If this node is a leaf, add the path to the answer. Otherwise, if it has left child, append a tuple of the left child along with the extended path. Likewise, if it has right child, append a tuple of the right child along with the extended path. When the queue is empty, all root to leaf paths have been collected. Return our path list. That's it. Let's hit the submit button. And boom, accepted again. The time complexity is big O of n because we visit each node once, and the space complexity is big O of n also, in the worst case because the queue can hold multiple nodes across levels. So there you have it, two solid ways to solve Leetcode 257 binary tree paths, a clean recursive depth first serve solution, and iterative breadth first serve solution using a queue. Enjoy this walkthrough? If this video got your problem solving gears spinning, keep the momentum going. Check out my other videos, and together we keep smashing these coding challenges while sharpening our skill one problem at a time. Thanks for joining me. Can't wait to see you in the next one.